Today we are going to see problems and viscosity. Note down the question. The space between two square plates square parallel plate square flat parallel plate is filled with oil. It's filled with oil. Each side each side of the plate is 60 centimeter and thickness of oil film is 12.5 millimeter. The upper plate upper plate which moves which moves at 2.5 meter per second requires a force of 98.1 Newton to maintain speed. By using this data, we need to measure. First thing is dynamic viscosity. Already know that which is a symbol denoted by mu of oil in the plane. So next parameter you need to measure is kinematic viscosity, which is denoted by the symbol is gamma of oil. We need to measure in terms of stroke. If specific gravity is 0.95, right? So actually, which we need to measure in terms of voice, right? So dynamic viscosity we need to calculate in terms of voice, and kinematic viscosity we have to measure in terms of stroke. So just you can read out the question. The space between the two square plate, you have to consider in terms of a parallel plate, right? So parallel plate means just you can assume like this. Considering a two parallel plate which is filled up of the oil, right? Where each side of the data is given, right? So here you can note down what are the data given to us, right? Area, each side of the data is given, which is 60 centimeter. So 60 centimeter means maybe form convert in terms of meter. So, right, actually we need a area, right? Each side is we can say as zero point 0.6 and zero point 0.6 meter square. And thickness of the film is given D, otherwise we can say as the DU, which is 12.5 millimeter is given, so you can convert in terms of meter, so you have to multiply with the parameter 10 power minus 3. And velocity is given, the upper plate which moves at a velocity of moves at a velocity denoted by the symbol u, which is 2.5 meter per second. So requires a force of 98.1 Newton, right? So these are the data given to us. From that, we have to identify the two various parameters, that is dynamic and kinematic, right? So now come to the part of a solution. So the first one is dynamic viscosity, denoted by the symbol mu, right? So actually, the formula shear stress. From this, we can able to say the dynamic viscosity, right? So what is the tau? First of all, we need to measure tau, right? The general formula for measuring tau is force by area. Force is 98.1 Newton and area is zero point 0.6 into zero point 0.6 meter square. So from that you can get some amount of value for your tau, right? So which is nothing but you go for the calculation, you get around 272 something, right? And what about the du and the dy? So thickness is given, dy is given, which is 12.5, and u is nothing but we can say du equal to u minus final velocity to initial velocity. Initial velocity is 0, final velocity is 2.5 is given. So from that you can able to identify the value of mu tau into du y by du, and tau value is approximately 273.5 Newton per meter square into uh, the value of y is given, which is thickness is given, which is 12.5 into 10 power minus 3 meter divided by u is given, which is 2.5 meter per second. Okay, right. So please go for the simplification here. If you simplify this, means you get the answer is around 1.3625, right? And meter cancel, rest will be a Newton second per meter into meter square. So actually answer asked in terms of poise, right? Already know that one poise equal to 1 divided by 10 Newton second per meter square. So just to multiply with the term 10, right? So finally the value of mu is 13.625 poise. And next parameter we need to measure is that kinematic viscosity, denoted by the symbol mu, right? So already know the formula for dynamic viscosity is the ratio of dynamic viscosity to the rho. Already we measured the dynamic viscosity, you know the value of density. So actually what is the fluid considered here, which is nothing, which is density of, sorry, we are considering an oil. So you have to measure the density of oil. So what is the formula for measuring the density of oil? So already we discussed about the property in specific gravity itself. So if you want to measure the density of a particular liquid means, so specific gravity, here you are considering oil, so specific gravity of oil into density of a standard, so liquid, which is nothing but water. So specific gravity of oil is given, which is 0.95, and density of water, which is 1000, right? So you get these 950 kilogram per meter cube. So this is the density of oil. So now you can substitute here, right? Here you are going to substitute in terms of SI units, so please you can substitute the value of SI in terms of dynamic viscosity. 1.6325 unit is Newton second per meter square divided by density of oil, which is 950 kilogram per meter cube. See, so now to go for the simplification, you get the value is around 0.001435, right? So what will happen of the unit here? See, actually, we ask it in terms of strokes. Stroke is nothing but a centimeter per square. So you have to form in terms of centimeter per square. So see how the unit conversion takes place here. Right? Already know that, right? So 1 Newton is nothing but we can say as kilogram meter per second square. So I can write like this: kilogram meter per second square into second per meter square, right? So divided by kilogram per meter cube. Okay, right. Then here the term second, one thing cancel, and rest will be a kilogram per meter into second into meter cube per kilogram. So again, kilogram can cancel. So the final unit you are getting as a meter square per second. So actually, if you want to say in terms of stroke, means one stroke is nothing but we know that one stroke is nothing but centimeter square per second. So you have to convert from meter into centimeter, right? So 0.001435. If you want to convert from meter into centimeter square means 1 meter actually, which is equal to here. So if you're saying as a meter square means 100 into 100, right? So convection factor is, right, 1 divided by 100 into 1 divided by 100. So we can say as 10 to the power 4 centimeter square per second. So finally, we can say 14.35 centimeter square per second is nothing but stroke. So this is the value of a kinematic viscosity. So next we will look at the another simple problem. Determine the viscosity of a liquid having kinematic viscosity. Which is 6 Stokes. Kinematic viscosity is 6 Stokes, and basically gravity is 1.9. So from that simply you have to measure what is the viscosity. Viscosity simply we can say as a viscosity, otherwise dynamic viscosity, mu. Actually we need to measure mu. So what is the given delta? Right? Kinematic viscosity mu is given, which is 6 Stokes. Specific gravity is 1.9 for a certain fluid. From that you have to what is the value of mu, right? So already know that the formula for measuring kinematic viscosity is dynamic viscosity by rho. So first of all, we should know what is the value of rho. So how can you measure the density of a certain liquid? specific gravity of a particular liquid multiplied with the density of a water. So particular specific gravity is given, which is 1.9, and water density is 1000 kilogram per meter cube. So finally we can able to get 1900 kilogram per meter cube of density of liquid, right? So what about the mu? Actually mu is mu the term you need to measure, gamma into rho. So gamma, which is 6 Stokes, here the density value in terms of kilogram per meter cube, that is SI unit. So you should convert from Stokes. Instead of Stoke, already know that 1 Stoke, which is equal to centimeter square per second, right? So here is a meter time MKS system. So you need to convert from this one. So 6 into 10 power minus 4 meter square per second, right? And it out in this, right? So if you simplify the equation, you get the value is 1.14, and what will be the actual unit of a mu, right? So generally we know that mu is, we can say as Newton second per meter square in terms of SI. So how the Newton second per meter square will be raised, right? See, so just a minute, I will change the color for the simple identification. The meter square we can write meter into meter, okay? And here simply multiply the term second in second in dividing and multiplying the value of second and second. So that if you are going for the multiply and dividing, there is no changes here, right? So we need to give a Newton, right? So already know that Newton is nothing but kilogram per meter second square. So you have to consider 1 meter and kilogram and second square, right? You are considering 1 kilogram meter per second square. Sorry, kilogram meter per second square. So kilogram per meter square is nothing but Newton. So I can say yes. 1 meter is considered second square kilogram, and rest will be a second. And in denominator we have a meter cube. So get the meter square, right? So suppose if you mention in terms of CGS system, right? So you need to convert from SI to CGS, that is in terms of poise, means simply you have to multiply with the value of 10, you get 11.4 poise.